Okay, in this example, we are going to talk about the difference in two squares. If you notice, I have a binomial here. In the binomial, we have an x squared, but there is no x to the first power. So otherwise, it's not in the standard form like we talked about before, ax squared plus bx plus c. If you notice, the bx is missing. That's because b is really 0, so 0 times x is 0. So this somehow gets canceled out. So we're trying to find factors. Remember, factors are numbers or letters that are multiplied together that give us the product, which is the answer. So if I'm asking for the factors of 20, I want to know two numbers multiplied together to give me 20. And we could say 4 times 5 or 1 times 20. When we have binomials, they usually specifically only have one set of factors. So what we're going to do is we're going to try to find the factors of x squared minus 64. And we've got to, when we're looking to see if it's the difference of two squares. So otherwise, when we say the difference of two squares, we're saying that they are the exact same thing. And I'm just giving you an example. Oh my gosh, I cannot write today. They're the exact same factors, except one's a minus and one's a plus. See the minus and plus? And usually when you have that, remember, they kind of like make a zero pair. And if you remember what we talked about just a few seconds ago, the middle part is zeroed out. So this part here is going to add up to be 0. So really we're just going to look at the two first terms and the last terms. And that'll help us determine the difference of two squares. So if I look at this, I'm going to go ahead and put a couple parentheses here. I have an x squared. Well, that means I know x times x is x squared. I know 64 is a perfect square because 8 times 8 is a perfect square. Now, since there's a negative in here, then I know that I could have a negative times a positive and get a negative. Now look, these are the difference of two squares. I mean, see how they're exactly the same except one is a negative, one's a positive. Now I can test this to make sure it works. So if I do this, x times x is x squared. X times 8 is a plus 8x. Negative 8 times x is a negative 8x. And then negative 8 times 64 is a negative 64. And then look right here in the middle term, just like we talked about before, that is a zero pair. Otherwise, that equals 0. So really my answer is x squared minus 64, which is exactly what we want before. So the difference of two squares, when we do this, if we're looking for an answer for the difference of two squares, this is it right here. Those are the factors that when multiplied together give you x squared minus 64. So if you do not see a middle term that's standard form, then you know that you probably have a difference of these squares. It's possible. Let's do another example. All right, so let's look at this. I don't have a middle term, but I do have a y squared and x squared, don't I? Is it possible that I could have a x squared plus a middle term like this and then have a something like that? Yes, it is possible. We do the same thing, no middle term, so we know it probably can be canceled out, so we probably know one's a minus and one's a plus automatically. So we're looking for square roots, perfect squares. Well, the square root of 9 is 3. And we have a y, we have two y's, so we'll put 3 here. So 3 times 3 is 9. The y squared means we have a y here and a y here. Let's look at 121. 121, the square root of 121, and you can take it and put it in your calculator, and you'll get 11. So we know it's 11. And again, there's an x on each side. 11x, 11x. Well, do they look the same? Yes, except one's a minus, one's a plus. We could test it by doing a check, but this is our answer. Because there's no middle term, and what we mean by that middle term is this little guy here. Since this is a 0, it's not there, we can try to do the perfect squares or the square roots of each thing. Let's do one more. All right, so look at this one. This is x to the 4th minus 81. Well, this may be a little challenging, but notice there's no middle term. If there's no middle term, let's just take each one and separate them. Well, x to the fourth is really x squared and x squared. We're going to take a minus and a plus because there's no middle term. They cancel each other. And the square root of 81 is 9. Let's look at this. Can I simplify this any further? Well, look at this one right here. That's a minus again. There's no middle term. So can I make another one of these? And we're going to change color on you. X times x makes x squared. There's no middle term, so one can be a minus, one can be a plus. And it's 9, so it can be 3 and 3. Let's look at the other one. Can I do the same thing with the other one? There is no middle term. So that means I can try to multiply and try to do it. Now, if I do this, watch what happens. And I'm going to do the different color. I don't want to do the same color here. So I'm going to change it so we can see what I'm talking about. Well, x times x is a negative, but I have a plus. It's not a negative. So that means they either both have to be negative or they both have to be plus. Now let's do the both plus first. And let's say 3. Well, now if I do this, look, this would be 3x. And if I did that, that would be 3x. And they're both pluses. That would make it 6x. So this would make a middle term. So this is not right. And so if I do a negative, would the negatives be the same? It'd be negative 3, negative 3x, and that would make it a negative 6x in the middle, which we can't have. We need 0 to be in the middle here. That means one has to be positive and one has to be negative. And in this case, I can't do this. When there's a plus, I can't make a difference of two squares. Now think about the word difference means subtract. So this will stay the same. So if I'm asked for the factors of this, I could write it like this. I could write it like this. So all I do is just move them around. You can move them around any way you want to. You get many different combinations, but either one is right.